All right, we're continuing the video from where we left off. Next one's end behaviors. Now, end behaviors is decided by two things. It's decided by the biggest power, and it's decided by if the coefficient is negative or positive. So, in that in mind,
You don't know me.
if it's negative
Who are you talking to?
and even, and positive and even,
You don't know me, son.
let me fix that. So if it's even and positive, it would look like up this and up this. So it'll be to positive infinity, it will be affinity. To negative infinity, it will be negative infinity. If it's negative, it'll be down this way. If it's odd, it's like a cube, so it looks like this. And if it's negative odd, it will look like this.
What is even?
Even. And it always odd. So in this case, this is an odd one that's positive. So it looks like this one over here, which means when we describe the end behavior is as x approaches negative infinity. Actually, I should say it like this. As x approaches infinity, it's going upwards, right? So then y is approaching infinity. And when x approaches negative infinity, it's going downwards to the when you go left. So y is going to negative infinity. Because
So
this is
when x is y, when x is negative, and so is y.
in this case, yeah.
Why?
Because it's odd, yeah.
So the next one's gonna be a different situation.
So this one, it's always based off the biggest power. So in this case, it's negative x to the fourth. So this is negative and even. So it's going to look like this one over here.
Yeah.
So as x goes to positive infinity, y goes downward, so that's negative infinity.
Wait,
And-
why?
Look at it. As I go to the right, it's going down. And when I go to the left, so x goes to negative infinity,
Why is
y is going down, so negative infinity.
So y is basically always negative.
In this case, yes. All right. Next one. Write a polynomial equation that has the following zeros. 0, negative 3, 2i. In other ways you could think of it is write a polynomial equation that has these answers. Which means before you FOIL, you know, like at the last step before you factor, it must have looked like an x plus 3, and an x minus 2i. Remember though, imaginaries always go with its correspondent. So if it has a negative 2i, you must be forced to have a plus 2i. So you're forced to have that because every imaginary has the imaginary pairing, the composite of it. From here, you're just foiling to make the equation.
It's multiple choice, right?
X squared plus 3x. Over here, I'm going to FOIL. X squared plus 4. Remember, what's happening here, it's negative 2i squared, but I squared is negative 1. So negative 2 times negative 1 is positive 4. Or negative 4, I should say, I squared.
Why is it minus 4i squared?
Negative 2i. Negative 2i times positive 2i is negative 4i squared. And then I squared is positive, so there. Then FOIL this. X to the fourth plus 3x to the third plus 4x squared plus 12x. And here would be a polynomial equation that has these following zeros. If I were to factor this, I would eventually get back to here.
But you don't have 2i or 0.
No, remember, when I say the following zeros, that means the answer, if I were to factor in set equal to 0, would be those.
Okay.
And I know I did because I started off with my answers causing that situation.
Yeah.
Okay. Next one. We're going to graph the following function. So in this case, the best thing to do is first find the zeros. So we're going to factor out x. And we got x cubed plus 2x squared minus 4x minus 8. Then, since you have 4 terms, that means you're going to be factored by grouping. So x, and I could take out an x squared here. So it's x plus 2. And over here, I could take out a negative 4. And it's x plus 2. Time to rewrite this. X squared minus 4, x plus 2. Just rewriting that grouping. And then, this is x minus 2, x plus 2, x plus 2.
So you can just cross out the x plus 2.
No, they're not on top or bottom of each other. So you're going to rewrite it as x minus 2, x plus 2, all that squared. This part squared, I should say.
Yeah.
Okay? Now, what's the worth of this? Like, why is this useful? What's useful about this is these are my zeros. So I know I have a point at 0, 2, and negative 2. So I know I should have a point here. I should have a point here.
The square doesn't matter.
The square will matter. I'll show you how. Also, from the original question, I know my end behaviors is an even and positive. It's even and positive, so it should kind of look like this, like an even parabola, a positive parabola. So I know my arrows should be up here and up here. Now, from here, you do that number line thing. Do you kind of remember this? Where it's negative 2, 0, 2. We're not really doing open close circles. But remember, we test each section. So I plug in here something in section A, let's say negative 3. In section B, negative 1. In section C, 1. D is going to be 3. So then we're going to plug it, and we're going to plug it into the factored form. This makes it easier. Remember, I don't actually care about the numbers. I just care if it's negative or positive. So in this case, I know from here, negative 3, this would be a negative. This would be a negative. And then negative 3 plus 2, but that's squared, so that's always going to become positive.
Does it say negative 2, 0, 2?
Yes. So I know this section's negative. And if you test each section, you'll get different things. In this case, though, remember, a double root means it should stay the same, while a single root, like over here, should change as you flip over. So it should look like negative 2 is a double root.
So ultimately,
So it bounces. Does that feel familiar when it bounces?
Yeah, but why?
what is that? What point? It's negative 2, 0.
I missed the dot. I'll just retry.
Why is it double?
Because there's 2 x plus 2's, which means it happens twice.
So wouldn't it be A, not B? The double root?
Say again?
Wouldn't
Oh, this should be positive, positive. My fault. Negative and then positive. That's fine. I started off wrong. My fault.
What is it? Positive, positive?
Negative, positive.
How do you know when it's a double root?
Because look at the root.
Look at where in the root is double root.
Oh, it's the power 2. This part is power 2.
Right, so how do I know when to put the positive root?
I plug in the first section and I follow from there.
Into the 1.
How do I know it's bouncing to the?
1.
You plug in 1 and you can see,
No, I'm saying like you see it's going to the 1 and then it's going to the negative 1.
yeah.
So how do you know that?
So you either think of it as roots. This is a double root, so that bounces. Well, these are single roots.
No, I understand why it bounces, but you see how you're moving it up to the 1. Does it matter like where you're doing the bounce?
Oh, no, it doesn't matter if you drew the bounce like this high or whatever. And remember, well, this is graphing, so I guess you have to do this. This is not multiple
Why
choice.
is it? Oh, never mind.
Okay. All right. Any other questions on this before I move on? Okay. Next one. Put in vertex form. Find the x vertex and intercepts. Find 5 points and put it in the table. So, to put it in vertex form, you got to use complete the square. So x squared minus 4x. I'm going to put a plus c here. That 3 I'm going to move outside. And to make sure it's balanced, if I do a plus c here, I got to do a minus c over here. Yeah, what's up?
Can you explain the even odd thing, like let's say it's from 1 to.
Sure, very quickly, okay? So in this one, because it's let's take the first one. You look at the biggest power, because the biggest power, the other ones don't matter when you go towards infinity. So this one is an odd power. So I know it's going to either look like a x, essentially, an x cubed like this, or an x cubed like this, upside down, I guess. And this, infinity, infinity, negative infinity, negative infinity.
But it seems like you plug in a positive number or plug in a negative number to that thing. Like if you plug in like -1, it's negative.
Oh yeah, you could think of it like that, sure.
That just plug random numbers.
Yeah, but you want to plug in like a relative big number, but it doesn't
Is that
matter.
EO?
Yes, even odds. So if you plugged in, let's say 10, this would be a big positive number, correct? So as you go positive, you get positive.
Okay.
If you plug in negative 10, that's going to be negative whatever big number, right? So it's negative infinity that way.
Why would the y?
It's actually not that hot in here.
Sounds soft.
It's cold, yeah.
Why would the y be negative? It's so hot in school.
Why would the y be negative? If I plug in a negative into here, it's an odd power. So it'll be a big negative number times 10, which is negative. Negative 10 to the fifth power will be negative 100,000.
For the next one, why is it?
Here's even and negative. So if I plug in, let's say 10, a positive 10, it will be negative 1,000 in that case, or 10,000. So as I plug in a positive number, I get out a negative number. If I plug in a negative number,
Oh.
it's still negative because it becomes a positive 10,000, but the negative is in front. If I plug in, let's say negative 10, that'd be positive 10,000, but it's negative 10,000. So it becomes negative. Or you could just think of it as this is squares and this is cubes. All right.
Are
And
you giving us any like
are you going to say formulas?
1, 2?
Yeah. Maybe. I don't know. All right. So this one is x squared minus 4x plus c, 3 minus c. So we have to add those c's to complete the square. We need to pick the perfect c. To pick the perfect c, we do b over 2 squared. Your b value is negative 4, so negative 4 over 2 squared happens to be positive 4. So this c will be a 4, and this c will be a 4. So to make it a little bit closer to each other, x squared minus 4x plus 4. 3 minus 4 is negative 1. This part here, you could factor. And it's always going to factor perfectly, because what multiplies a 4? That adds a negative 4. Negative 2 and negative 2. Why would I multiply the negative? This one?
Yeah.
It's minus 1. It's not times the negative 1. Minus 1. So now it's in vertex form. So y equals x squared, x minus 2 squared minus 1. Remember, this is your h value and this is your k value. So if I want my vertex, the h value is flipped while the k value isn't. So 2 comma negative 1. The y-intercept, you could just plug in 0 into the equation. This would disappear, this would disappear. So it's just your c value, which is 0 comma 3. And your x-intercept is where it hits the x-axis. So in this case, let's just graph it a little bit. Comma 2, comma negative 1. I know it's 0, comma 3. 1, 2, 3. And then, well, I was supposed to make a table, my fault. So I make my table. Remember, in the middle of your table is always your vertex. So I'm going to put the vertex purposely in the middle. 2, comma negative 1. Then I'm going to go 2 smaller and 2 bigger. So 1 and 0. And 3 and 4. From here, I can figure out the next value. If I plug in 1 into the equation to do it very quickly, you could technically plug it into the vertex form or the original form, whatever's easier for you. But that's going to be 0, 0. If you plug in 0 in the equation, it'll be 3, 3. So I graph those points. And then I just graph my parabola.
You're plugging into the beginning equation?
You could plug it into either one, either your vertex form or the beginning one. It'll give you the same answer, assuming you did the work correctly. Your x-intercepts is where it hits the x-axis. So either you physically look at it where it hits the x-axis,
Is that, what is that?
or you physically look at these points.
Wait, what, it's hitting 1 and 3?
1, comma 3?
Yeah. Or like 0, 1, whatever it is.
That's 0, comma 3.
Okay.
1, comma 0. 2, comma negative 1.
Wait,
3, comma 0. 4, comma 3.
4?
4, comma 3, yeah. And that's right here. And where it hits the x-intercepts is where y equals 0, which in this case is, technically it would look like this, 1 and 3.
Will it always go out 1, up 1, out 1, up 3?
So the trick for that is it will, assuming you're moving one space here, right?
Yeah.
It will always be your a value, and then it will be 3 times your a value, and then the next one will be 5 times your a value, 7 times your a value. So in this case, since your a value is 1, you would add 1, which is 0. Then you would add 3 times 1, which is 3.
Right.
If it was 2 in the a value, you would add 2 and then add 6. That's a trick to it, but remember also you technically have you not technically, you do have your calculator throughout the whole test. You can always just slap that into the table graph. Oh, any more questions on this before I move on? All right. Next one. What transformations occur from this compared to y cubed? Same process as always the transformations. The a value here means it's a vertical stretch of 3. Your h value here, remember, is negative 5 secretly, so that's left 5. And then your y value here is your k, or your k value, I'm sorry, means you're going down 1. Over here, write the equation of your quadratic function that gives the vertex of this, and that passes through this point. So, we know that the vertex should be 2, comma negative 1, and we know it should pass through 5, comma 11. So usually I have my vertex form as this. Y equals a, x minus h squared plus k. Remember, h and k is your x and y, your vertex. X and y is a particular point. In this case, I have a non-vertex particular point here. So I can plug in 11 equals, I don't know what a is, and realistically that's what I'm trying to find. X is 5 minus my h, which is 2 squared, plus the k value, or my vertex of the y of the vertex, which is negative 1, or minus 1. I just plugged everything in that I knew. Then it's just algebra from there. 11 equals a, 3 squared minus 1, 9a minus 1 equals 11, 12 equals 9a, a equals 4 over 3. Which means your answer here is y equals 4 over 3, x minus 2 minus 1. In terms of multiple choice, I would have it like this. I would have it where 1 and 2 swapped. I probably would have it where I put 5, 11 for where the vertex is. And I probably would have it if you did it as if 5 and 11 was the vertex and 2 and 1 was the other values. That would be my multiple choice questions. Go ahead.
So this be a vertical stretch?
No, it's more than 1, so it's still a vertical stretch by 4/3. But you can think of it as 1/3 bigger than normal. All right, divide the following polynomial by long division. So long division, you put the bottom or the divisor on the outside, and then you put your full-on equation in the inside. Remember, if you have any gaps, you have to include that. In this case, it doesn't have that. So 4x cubed minus 7x squared minus 11x plus 5.
So the first thing you do is x squared.
So what you ask yourself is, what do I need to multiply this number to match this number? And in that, I need to have x squared. Remember, you want to put them in the correct column, so x squared belongs here, okay? If it's a little shifted, it really doesn't matter, but so.
You're the first text, right?
Yes. So I'm going to multiply this by x squared. I'll use green. So in this case, it'll be 4x cubed, which is perfect. I wanted it to match. X squared times 5 plus 5x squared. That or subtract it. So you're going to subtract it down. This becomes 0, which was your goal. That's good. Negative 7 minus 5 is negative 12x squared. So my next goal is to make my 4x match negative 12x squared. So what would I multiply? Negative 3x. And let me bring down this negative 11x. So I'm going to take negative 3x and multiply it here and here. So negative 12x squared, they match, so that's good. Negative 3x times 5, negative 15x. Subtract down. These cancel out, which is perfect. And it's going to be positive 4x. Bring down this 5. In this case, what do I need to give 4x to match 4x? Just a 1. 4x plus 5. Subtract down. 0. You have a 0 remainder. Remember, though, if you do have a remainder that's, let's say, not 0, you would just put your answer. This would be your answer in the question. X squared minus 3x plus 1. But if for some reason you had a non-remainder 0, remember it's going to be whatever your number is. Let's put like n. Whatever your number is over your divisor, 4x plus 5, okay?
I just try remainder.
No, it's not. You can't just put r. Or it's a multiple choice question, so it won't look like that. That's like that. So that's your answer here. All right. Divide the... Yeah, sure. The next one is divide the following one with synthetic division. It only works because this is x plus 2. It can't be like... You can't have any value in front of the x, okay? So in this case, we're going to change it. It's going to be negative 2 here. And we kind of make an upside down division symbol. Remember, you just take the coefficients in front. So 5, 3, negative 6, 8.
Why the x?
Hmm?
Oh, you forget the x's, right?
You don't need the x's now when you synthetic division. Or the x's show up later. We'll say that.
Look at the values.
So you bring down the 5, and then you multiply 5 and negative 2, which would be negative 10. Then you add them together.
So negative 7.
Should be negative 7.
Positive 14.
So multiply by negative 2 is positive 14.
14
Then add that together again. That'll be 8. And then move that up. Negative 16. And then this would be negative 8. So how do we write our answer? This was x to the third, so all the powers went down 1. So x to the second, x to the first, no x. And this is going to be our remainder. So our answer is going to look like, I'll write it over here, 5x squared minus 7x plus 8 minus 8 over x plus 2. Okay, next one, simplify some I terms or imaginary complex numbers. Remember, you're just combining like terms. So it's negative 3 plus 3i. In your multiple choice, it will always be the regular number or the real number first and the imaginary number second. This one is going to be, you distribute the 5i. So it's going to be 65i. minus 40i squared. But reminder, what is I squared again? It is negative 1. So I could change that I squared to a negative 1. So that's going to be positive 40. So the answer in the multiple choice will look like this. 40 plus 65. I cubed would be negative I. I to the fourth would be just positive 1. Because it would be negative 1 times negative 1. Next one, we're going to FOIL 2 minus 5i, 2 minus 5i. So you're going to FOIL. It's going to be 4 minus 20i plus 25i squared. Remember, I squared is negative 1. So it's 4 minus 25, or negative 21 minus 20i. Of course, I FOIL that faster than normal, but if you want to take the long way, draw the arrows, that's fine. Yeah. This one. No.
Wait, scroll up.
Yeah, sure. They gave it to me because I'm a good worker. All right, next one. Find all the zeros given that 2i is one of my zeros. So what I could do is use synthetic division. So 2i is going to be one of my values. And I'm going to use synthetic division to work from here. Let me make with more space. So let's do 2i. And I'm going to put 1. 1. Yeah, but either because I'm using 2i, I'm going to eventually use negative 2i anyway. Because they're always paired. So it doesn't matter if you do it first or second. Negative 8, 4, and negative 48. So for here, we're going to bring down the 1. 1 times 2i, 2i. We're going to add these together. They can't be added together, so it's just going to be 1 plus 2i. Now we're going to multiply this with 2i. So that's going to be 2i. 2i times 2i is 4i squared, or minus 4. Add that together. That's 2i minus 12. Yep, negative 12. Then we're going to multiply this again. Let me shift it so it's a little bit more clear. 4 and negative 48.
Wait, isn't it 4?
It is 4. 2i minus 4. Yeah. And then I add down. Negative 8 plus negative 4 is negative 12. Then I do it again. In this case, it's going to be 2i times 2i is negative 4i squared, which is just positive 4. Positive 4. No, negative 4, I mean. So it's going to be negative 4 minus 24i. 4 plus negative 4 is 0, so it's just negative 24i. Negative 24i times 2i is going to be negative 48i squared, or positive 48, which means this is 0. You know you did it correctly in this case, because I told you it's 0, that you ended up with a 0 at the end. Now, with every I, you also have the opposite I, which is the negative 2i. So you're basically doing the same thing, but with negative 2i. So it's 1 multiplied by negative 2i. Luckily, this part's easier. The 2i's cancel out, so it's a 1. Multiplied by negative 2i. Oh, the 2i's cancel out. It's always going to end up like this if you do it correctly. And then negative 12. Negative 2i times negative 12 is positive 24i, which cancels out to 0. Remember that will always happen. So we know 2i is a 0, negative 2i is a 0. Next thing, this is the same thing as saying x squared x and 1. So I can rewrite it as x squared minus or plus x minus 12. You could technically continue synthetic division, but you can just see it's factorable
Why would it not be 0?
if you made a mistake.
No, like
Oh, then you picked the wrong thing. That's when you have to find it like this one. When you have to do it
no,
wrong.
but because you did this, you didn't have to do that if that's true, because since it's 2i negative 2i, you just flipped it and said 2i and negative 2i are both zeros and column A. So that's
Yeah, but I need all the zeros, so I needed to get to this part, which is important, because then I can factor this as x plus 4 and x minus 3. Let's say equals 0. Split and solve. So negative 4 is one of my answers, and positive 3 is the answer. So negative 4 and positive 3 is my answer. But you're right. Since from the beginning, I knew it was I and 2i, negative 2i.
Was this whole like chart for problem 13?
That whole synthetic division was for problem 13.
If you do negative 2i first, we still get the same answer.
Say that one more time.
If you do like the negative 2i first, then that is the you get the right answer.
Yeah. But actually, I was right with my thing. The 0 is 2i. If you wrote it like this, it would be x minus 2i, but it goes here as 2i.
So it's next R is negative 2i.
You could, but I'm just saying like this matches this.
Yeah.
You don't flip it when you put it in the synthetic. Like it's flipped because before you answer the question, like x minus 2i, it's flipped.
Okay.
So if I said it was like 3, you would not put negative 3. You would just put 3. Okay. All right. Next one, find all the zeros. So this was the tougher one, where you have to figure out what are your possible zeros. This means you had to do Q over P, where Q is all the factors and P is all the factors is of the last number and the first number. So it was 2 and 1, and this was 2 and 1. So you make all the fractions, 2 over 2, 2 over 1, 1 over 2, and 1 over 1. You remember, cancel out anything that's repeated. In this case, 2 into 2 and 1 over 1 is the same thing. So your possible answers could be positive negative 2, positive negative a half, positive negative 1. These are your possible answers. So you set up your synthetic division, and you pick one of them to start off with. I'm going to put positive 1 because I'm pretty sure 1 was one of the answers here. Go ahead. If I remember correctly, 1 was one of the answers. So.
Hello?
Now remember, if your final part does not become 0, then it did not work. So let's see. 2 times 1 is 2. 5 times 1 is 5. 1 times 1 is 1. Negative 2 times 1 is negative 2. 0. So one of my answers is definitely 0. Or 1, I'm sorry. Now I do it again. I have to pick another number. I think what was another one? Was negative 1 one of the answers? Let me check. 2, negative 2, 4. I think negative 1 was another answer. But in this situation, the only sucky part about this, you kind of guess and check. But remember, since you have multiple choice, what you could actually, I'll show you after I get the answers actually. So let's do negative 2. That's 3. Negative 3. Negative 2. 2. 0.
Well, would it be
Not 0?
P over Q and the other way around? Like P is greater than Q, that thing?
That's when you graph with asymptotes, which I think is the next test.
Oh.
Now you have this, which is 2x squared plus 3x minus 2. You could just factor this normally. X squared plus 3x minus 4. I bring the 2 over here. Things that multiply to negative 4, that adds to 3. X plus 4, x minus 1. Then I could divide both of these by 2 because I borrowed a 2. So x plus 2, 2x minus 1. and then solve for each one. Negative 2 is one of my other answers, and 1/2 is another answer. So in your multiple choice, it'll be, technically we'll have this kind of bracket. Negative 1, 1, 1/2, and negative 2. Why that bracket?
No, why did you like stop doing after negative one synthetic division?
So now I'm left with x squared, x. I could continue synthetic divisioning, but I'm still guessing. Is it 2, 2, 1, 1, negative 1? What's easier is factoring that I could guarantee to get the answers anyway.
So once you can factor,
You should factor, yeah. The only reason we use synthetic division ever is just because we can't factor the situation. We would never choose synthetic division over factor. Okay? Now, as a reminder, since it's multiple choice, what you could do is these numbers are going to be one of your options, right? Or some of your options. So what you could do is just take negative 1 and plug it into the equation quickly and see if the result is 0. If that's so, then yeah, it worked. Then you plug in the next number and see if it's 0. Then that works. But let's say you had a situation where it's like negative 1/2. You plug it in and it's not 0. You could cross out that option because it can't be negative 1/2. You could just take the numbers and plug it in and see if it causes the whole thing to be 0. Since it's multiple choice, you have the advantage of not having to do that.
class is home.
I know. Tell about your TikToks, man.
Yeah, after like
Wait, can you go back?
Yeah, sure. And then, I'm going to call it because I don't think I have time to even start the next one.
the next one's like long, right?
All these questions are long, man.
What does that say? 2x.
How long do we have to take
2x
these
squared?
tests?
You got 2 hours.
2 hours?
2x,
Yeah.
3x. Is that like square?
Where are we talking about? 2x, 3x? 2x squared, yeah. What do you say?
It's just short amount of time.
I think that's the opposite of short.